The objective of this lesson is for students to recognize a pattern that leads to an understanding of the invert and multiply algorithm for division of fractions. The problems in this lesson will be the partitive interpretation of division. Partitive interpretation is a form of division where the number of groups is known, but the size of each group is unknown. Let's solve the following problem. I have 5 cakes in 1/3 of a container. How much cake will fit in one whole container? The question to ask with partitive interpretation division problems is how much for one whole? In this diagram, the blue represents the whole container and the red marks represent thirds. 5 cakes fit into 1/3 of the container. If 5 cakes are put into each of the next 2 sections of the container, there will be a total of 15 cakes. 5 divided by 1/3 equals 15. Let's solve another problem. I have 3 cakes in 3/4 of a container. How much cake will fit in one whole container? How much cake is in the whole container when 3 cakes are distributed into 3/4 of the container? To solve this problem, we will draw a container divided into 4 sections. 3/4 is represented by 3 of the sections. Since we have 3 cakes, there will be 1 cake in each section. If 3 is enough for 3/4, how much is enough for 4/4 or one whole? If we place 1 cake in the 4th section, then we have a total of 4 cakes. 3 divided by 3/4 equals 4. Let's solve another problem. 8 cakes fit in 2/3 of a container. How much cake will fit in one whole container? How much is in the whole container when 8 is distributed into 2/3 of the container? To solve this problem, draw a container divided into 3 sections. 2/3 is represented by 2 sections. Since we have 8 cakes to divide into 2 sections, each section will have 4 cakes, since 8 divided by 4 equals 2. That means 4 cakes will also fit into the final third of the container for a total of 12 cakes. 8 divided by 2/3 equals 12. Let's solve one last problem. 10 cakes fit in 5/6 of a container. How much cake will fit in one whole container? How much is in the whole container when 10 is distributed into 5/6 of the container? To solve this problem, let's draw a container divided into 6 sections. The 5/6 is represented by 5 sections. Since we have 10 cakes, 2 will go into each of the 5 sections, since 10 divided by 5 equals 2. If 10 is enough for 5/6, how much is enough for 6/6 or one whole? If we place 2 cakes in the final section, we have a total of 12 cakes. 10 divided by 5/6 equals 12. In summary, let's look at the pattern used to solve these problems. Notice in each problem, we are dividing by the numerator and then multiplying by the denominator of the divisor. This is called the invert and multiply algorithm. The objective of this lesson was to recognize a pattern that will lead to an understanding of the invert and multiply algorithm for division of fractions. We met this objective by asking how much for one whole, and then drawing models to aid in solving the division problems. We then recognized the invert and multiply pattern in the division equations for the problems we solved.